Thank you. I'm Emanuele Rampichini. I work at Spreaker. I'm an application engineer working on different things, mainly front end. And today I'm going to tell you how to push a real-world React.js in production without sleeping like that. That's the idea. The first thing, so you're building a large React.js single-page application. That's what you're doing. And the first thing that you have to do to sleep well is asking yourself a question. Do you need it? Are you really sure that you need to do that? You have to be very sure. You have to be very motivated about that. Because single-page applications are complex. There's a lot of things going on. If something breaks on a single line of your JS, the application will break. And a page reload is not going to help. It can break your links. It can break the user experience of your customers. So don't do it just because it's cool and it's the thing of the moment, but do it when you really need it, when it gives you value. That's the first lesson. If you can respond to this question that you don't need it, okay, you can sleep well and you can go out of this room and you don't need to know anything more. The usual approach about pushing an application to production, a front-end application, is the push and pray approach. So basically, you write some code, you test it on your machine, looks okay, let's ship it. And let's see what happens. It's widely adopted, so someone could say maybe it's good. I don't think so. Fortunately, we have two superheroes. One not so much. This is Robin, not so good. That are here to help us, and they are testing and monitoring. A crucial part of your work when you develop a front-end application is going to be ensure that everything works and be sure that what was built is still working. The cool thing is that monitoring a React.js application, a single-page application, is crucial. It's important. You have to know what's happening on the clients that are using your application. But it's super easy. It's super easy. There's plenty of tools that you can buy with few bucks, and with just one liner, they're gonna do a lot for you. I just put 3 links here: Sentry, New Relic, Track.js. They're tools that provide stack trace collection from your user using your application. They give you real-time notification if something is going bad in production, and every one of these tools can integrate with your email or push notification, or it's gonna submit a message on the Slack channel. This is a reactive way to manage your code quality. So you can see an error, you know that there's an error, you have a stack trace, and you can fix it fast. That's one thing, and it's crucial. Even if you don't do any testing, please do the monitoring. Make your users happy. What about testing? Testing is not so easy. It's a totally different beast. It's not something that you can do with one liner and an external service. It's not like that. Let's start by defining some testing concept. Let's define some families, some classes of tests that we can implement on our front-end application. We have the unit test. basically unit tests are testing one single unit of your code. And then we have integration tests, and it's testing a piece of your architectural stack with more than one unit collaborating to give a result. Then you have the end-to-end test. An end-to-end test is it can be automated or can be manual, but it's a test that traverses all your software stack. So basically, is someone interacting with your application. And then you have manual and device tests, the ones that are very expensive, but you have to do them. Let's see how we can fit these classes of tests in a ReactJS plus Redux application. I'm talking about Redux because one of the main side effect of using Redux is that unit testing becomes very easy. Before seeing these classes, I'm going to tell you what I'm using right now to do tests in my in the application I'm working with. It's nothing fancy. It's nothing too new. It's just I'm using the Karma runner to run the unit test on a headless browser like Phantom.js on the continuous integration machine. And the cool thing about Karma is that you can attach different browsers and run your test suite across multiple browsers. And that's good because sometimes you just want to run the unit tests on a cell phone or run the unit tests on Firefox, on Internet Explorer, and so on and so on. So it's working, and your tests are working in a real browser. That's the thing. It's not a virtual environment in Node.js. And then I'm using plain Jasmine. So when you configure Karma, you're going to have Jasmine to define your test suite. And I think it's enough. You don't need more tooling. All this tool, I'm using all this tool with Webpack to use ES6 functionality. And just Google for it. I'm not going to spend too much time explaining how to set it up, but if you just Google for it, you're going to find a lot of articles explaining how to do a proper setup of a test environment like that. And if you're interested in that, just ping me after the talk, and I can show you how it's implemented in a real-world project. So let's start with the most simple thing. Unit testing a reducer. Unit testing a reducer function, it's that simple. It's a piece of cake, really. We're just testing pure function. A reducer is a function that takes a state and an action and gives you another state. Reducers are composable, so you can test the outer reducer or the small reducer. And it's just easy. This kind of test you have to do a lot of these tests because they ensure the correctness of your state mutation logic, of the state, the application state. How can you do it? It's simple. Here I just define a simple helper function, because at the end, a reducer is just applying a reduce on action and take the next state given the action and the current state. That's it. And that's a test. For example, we have a simple counter, and we want to test that given a counter, we can increment it. It's something very simple. We have an undefined initial state. Then we have a collection of actions. We define them. And then we say what is our expected state. And we just expect the final state to be the expected one using the function you just seen. You can do a lot of tests like that. If you have complex business logic, you can cover all your business logic with tests like this. The cool thing is that if you don't want to write a lot of all your initial state, you can apply a lot of action and just drive your state in the right position, pushing action, and then test the final state. That's how I did here. Unit testing, components rendering. Yeah, that is a piece of cake too. If you're working with Redux, probably you're going with purely stateless component, and what you want to know is that given the right props to the component, you get the expected output. It's quite simple, and for doing that, I'm just using simple tools, test utils, React test utils. I'm using the shallow renderer. This is very interesting because it makes simple to test only the one level deep nesting of components. So you don't have to care about nested components, and you only test the logic of the outer one. That's good because if you have a very complex and nested component tree with behavior, for example, with lifecycle callbacks, it's going to be a hell to test it. But with the shallow render, you can do it one piece at a time, even if it's nested. And then here I just put another couple of links. React shallow test utils. This is a DOM searching library on the virtual DOM, on the rendered output, and Enzyme. Enzyme from Airbnb gives you a nice query language to test your components. It's quite cool, but I think if you're starting testing, just start from the basics. Start from the most basic tool you can find. Then you're gonna feel the need for something better, and you're gonna pick an advanced tool. This is a very dumb component, not so nice. Actually, it's just a note that doesn't render anything if there's no text, so it returns the null, or return the note if there's something. And a unit test here looks like this. With a shallow renderer, you create your renderer, you render the component, you get the output, you render the component passing it the properties. You get the output, and you do an expectation on the output. And this test is quite simple. For example, here we have the two cases. Nothing is passed, null, note is provided, do some assertion on the output. Simple. What about connected components? We're talking about a Redux application. Basically, you can do the same. It's not so different. This is the same, yeah, it's the same component. The note here is not anymore a string as an object. It has an ID and a label. And what you can do is, as you can see, export, as named export, the mapping functions for the state, for the internal state, and for the action with the dispatch, and the class. And default export the connected component. What are you gonna do on your test is import all the named import. So you're not importing the connected component, but just the mapping function and the named component. And what you do, you can build your props object that are coming from the states using the map function. Bind the action with a fake function. You don't need the real dispatch right now. And then just render the component with the properties coming from the two mapping functions. And the test is quite simple. I've seen a lot of time testing connected component without using the mapping function. I strongly advise to do it because basically you are testing a little bit more. It covers a little bit more your logic. Usually the mapping logic is very simple, but it's better to use it than to mock it on every test. Because if you change it, your test is going to break, and that's good. Okay, this is the success case. So we just tested that in the other case there was no component rendered, and now we're testing that does something. Unit testing components behavior. That was about rendering and about what was the presentation of the component. But then we want to test the interaction with the component. And this is quite easy. It's not difficult, these two. You just want to test that when a lifecycle callback gets called, when a button gets clicked, something happens. And in a specific way, you want to know that the right action is dispatched, okay? You can use the get output to click on a specific button, or you can use the get mounted instance on the renderer to get the component and call directly the lifecycle callbacks. These are two useful functions. And what we're gonna do here is the same component with the delete node action binded, and we're gonna see the test code. It should delete a node if I click on the delete button. So we're gonna create our mapped state starting from our state with a node. We're gonna create our action props, and then we're gonna spy on the delete node action with Jasmine spies. If you're using Jasmine, you can spy on any function. And that, what you're gonna do is render the output, render the component, get the output, find the button, invoke the click, and then do an assertion on a spy. So we expect that the delete node action was called with 1. And that's it. It's quite simple. You're not testing everything. You're just testing the unit. You're testing that when I click there, the action gets dispatched. I don't want to know what happened next. I don't care. It's a unit test. Unit testing, that's what we can do. Unit testing middleware and reach action in general. If you're using thunk middleware, it's something quite common. You have some logic in your action, in your reach actions. You just want to assure that a reach action dispatches the right simple action in the right order to our store when some preconditions are met. Some useful tools here to do this kind of tests are Redux mock store. It's a store that just records your action, and you can get out the action from the store to test them. And as usual, Jasmine spies. So we have our action, the delete node action, and this is a thunk action, a reach action. We do a call to an API, and then we have the success and the error. So the typical tree action. Oh, I forgot the. No, it's okay. That's everything. And that's the action. How can we test that? It's simple. We create a mock store, passing our thunk middleware, and we import our delete node action. Now here we are creating our mock store with an empty initial state. We don't need it now because we're not making decision in the action based on the state. We're not using the second parameter, the get state. And then what you can do, you can spy on the API. Here we have an API module, and we spy on the call, on the code that is going to do the actual call. And you return a promise that resolves. So you have a success. The node was deleted. Then what you can do is just dispatch to the mock store your action, and then do an expectation about what action have been dispatched to your store. So here you're doing it with the resolve, and here you're doing with a promise reject. So you're testing both the cases. It's quite crucial when you're writing thunk action to always return a promise. So if you don't return a promise, you're not going to be able to hook up on the then state of your store. So every thunk action should be a promise chain returning a resolve or a reject. That's the thing. Midway testing. Okay, how do we put these things together? Sometimes we just want to test a component interacting with a reducer and possibly with a reach action. That's something interesting to do. I'm not gonna show you an example here. If you're interested to the details, I can show how to do that. But the idea here is that you're gonna mock the lower possible level on your application. That in the case of an API call is the AJAX request to your server, and everything else is not mocked. You're using the right action and everything. For mocking the backend, this is quite useful. Even if you have some legacy application, you can use Jasmine AJAX. It can be installed before your test suite, and you can drive it basically wraps the original code, the original XHR code, and makes you respond with something you defined. The setup of this kind of test can be tricky because you have to pick the pieces of your architecture you need to test a single component, so you have to understand how it works. But they are quite useful. They cover a little bit more. Then we have the end-to-end testing, the real testing, and this is not related to React, not relating to React at all. You can do end-to-end testing with a public website that is not yours. You can do that. And the idea here is you need a WebDriver to drive your web browser to do something and to do expectation on the result only based on the DOM, and that's it. You're not using anything else. So it's agnostic from the platform. These kind of tests are quite slow to run because you have to spin up an actual browser and interact with it and call the real API. And the tricky part here is that you require full control of your backend data because you have to be able to load fixture on your backend to ensure that the test is running in a controlled environment that you know that is going to be always the same. For this kind of tests, I'm not going to lie, I'm not doing a lot of that because they are quite difficult to maintain, and they don't, if you don't have a critical path that is making money flow in your company, just don't do it. Because it's okay to see that nothing breaks, but they're quite clunky to do, slow to execute, and they take a lot of time. I'm using Protractor here. It's just a glorified Selenium. It's useful. It was made by the Angular team, but basically it's just Selenium. So you can use a lot of things. two things you have to know when you're using protractor without Angular is that you have to disable the synchronization with the Angular framework that makes easier to test async application on Angular, and look at the expected condition on the API spec. The expected condition are condition you can give to the DOM async condition. So wait for something to happen, wait for a selector to be present, wait for the root to change. So you can do async testing. Manual testing on multiple devices. These tests are sadly the most expensive. Still, they are crucial. You have to do them if you want to assure your user to be happy with this Android 2.2 phone. Okay, it's not gonna make him happy, but he's happy. Be sure to have as many real devices as you can. You can build your own device wall at home. It's a nice pet project. Always have a staging environment that maps in the best possible way the production one. So do that and do internal testing. So have a staging area, make your team using it. And when you can, adopt canary deployment strategy. If you are not sure about a feature, just reduce the number of users that are gonna impact. And then you can open up the feature to more users. That's a good strategy. We have a device wall. That's a pet project from my CTO. He did it at home. And we're doing some tests with that. And okay, it's not huge, but we built it, and it was a cool side project. So the thing is that, wow, there's a lot of tests to do and write and to maintain, and not a lot of time. And I know you're feeling that. I can feel you. I know that feeling. It happens every time. Keep calm, because it's okay not to test everything. The first error that I see when someone approaches testing is that, okay, now I'm gonna do the things right, I'm gonna test everything, and then you spend 1 week just writing tests, no feature is shipped, the management is furious with you and tell you what the hell you're doing, and then you stop writing them. So it's okay, it's okay. Just know that at first you're gonna be super slow at doing that. You're gonna do mistake like everything, like when you started to learn how to program, and then you're gonna be better. And I'm gonna leave you one tip. If you don't have time to implement tests, just take some time to write the test definition, so the string that defines the test case, and mark them as skipped. When you have some slack time, you can add coverage to your project. So writing the test definition doesn't take a lot of time, and you have to do it when you're developing. You're doing it in an implicit way. So just write it down and mark them as skipped. So your test runner is gonna tell you, wow, you have a great net of tests that are not implemented yet, but still you have a point to start when you have some time to do that. That's it. We are hiring at Spreaker, and if you're interested or you just want a T-shirt, we have some T-shirt. Just ping me, and or ask me anything, ask me questions, and I'm gonna throw you a T-shirt. Thank you.